you can find updated information with. What does the Android platform or Android stack look like? As I said, 3 basic layers. You have the kernel down below, and then you have the libraries and the application framework, which is the middleware, and then you have your applications on top. Let's look at each one of these in a bit more detail as we go along, examining one by one, starting with applications. Applications are your first point of contact with an Android platform. That's how you make use of Android. You invoke applications and then you use them in practice. Android itself comes with a certain group of applications that are already built into standard Android. Things like, for example, email, SMS, calendar, maps, browser, contacts. All these are replaceable. Okay? If you don't like the stock application, you can always throw it away and then replace it with a better or your chosen version of this application. So these are the core applications that come with Android. So if you invoke, for example, the emulator in the Android IDE, you will notice that all these are already present in the emulator when you invoke it. In addition, you can write your own applications. All applications are created equal. Okay? There is no such thing like these are the more important applications than your application that you create. Everybody is treated equally. So in that sense, you can replace these by one of your own applications, which provides similar functionality if you so choose. Application development in Android is based around Java. So I assume that many of you know Java already. How many of you don't know Java? 1. Anybody else who doesn't know Java? 2. Anybody else? 3. Me included. Well, as you realize, if I can write Android applications, I'm sure you can write Android applications too. Okay? In terms of using Java itself, if you're familiar with C, C++, no big deal. Just open a Java book and then you'll learn up a lot of things. All these languages look similar to each other anyway. And you will see increasing use of libraries and so on. So that is one thing that you will see. A lot of method calls to library functions that are provided. So that is something, even if you know Java, working with Android is slightly different, so you need to keep that in mind. The use of packages as you use in Java is very much there even in Android too. And so if you are familiar with Eclipse IDE, I think that should be very straightforward for you. And once you install the SDK, whatever package you need will be automatically imported into your application that you create and so on. Down below, Android provides this application framework which captures certain key functionalities that are provided for users. Things like the package manager, activity manager, telephony manager, window manager, and so on. You see a whole bunch of managers there, content providers, and so on. We will see some of these in more detail as we go along in each section. For example, we'll look a little bit at the telephony manager later on. We'll look at the location manager when we talk about location and maps in Android. We'll look at notification manager when we talk about broadcast receivers in one of the later chapters. We'll look at the view system when I talk to you about the user interface development. We'll look at content providers when I talk to you a little more about databases and making use of existing data within the system, and so on and so forth. Okay? Now, all these are exposed to application developers in the form of APIs. If you're familiar with using APIs for other platforms, this should not be that difficult for you to use in practice. This is a summary of what each of these frameworks provide for you. As I said, the view system is primarily designed to support the user interface. We will go through some of these in more detail in the immediate next chapter. Content provider dealing with sharing and exposing of data that is stored by a certain application to other applications and so on. We'll look at that in databases. Resource manager related to providing access to graphics, layout, and so on. Resource manager, we will use it in a form in the way you declare layouts and so on in Android, and the way you declare strings and XML files and so on in Android. That we will see in more detail. This deals with delivering notifications to the status bar and so on. The notification manager will have a couple of applications where we make use of that in more detail. This is the one that manages the life cycle of a component. I'll talk more about the activity manager and life cycle in the later part of this chapter itself. Okay, so this is the next layer, the layer below the application layer. So all applications make use of the APIs exposed by these managers. So if you want location information, ask the location manager. Call the methods in the location manager to provide information for you. If you need to deliver notifications to the user, send it to the notification manager and say, deliver this notification to the user, and the notification manager takes care of it for you. If you need to make use of resources, like for example, different colors that you use in your user interface, different strings that you use in your application and so on, resource manager enables you to have access to them and so on. In addition, Android comes with a whole bunch of libraries which are underneath and provide you with functionalities that might be of use to you. One of them that you might directly deal with is OpenGLES. The second one is SQLite and WebKit if you're tinkering around with browser inside there. Surface Manager will deal with this in terms of 2D and 3D graphics. We'll deal with the media framework if you are working with audio and video data. We'll look at a little bit more of that. libc, if you are familiar with Unix, you know what libc is. It's the underlying libraries that provides much of the functionality in Unix. SSL, I'm sure you've heard that term before. If you need, all these are there as part of libraries in Android. Okay, the libc itself is a optimized version of libc that is used in Android called as Bionic. This is the System C version of libc that is used in practice. We will look at some of these a bit more as we go along in the later parts of this course. Besides the library, you have the runtime. The runtime, together with the Dalvik virtual machine, that is the one that supports your applications that you develop in Java. So even though underneath things are done, some of the things are done in C, C++, application development at the upper layer is all done in Java. Well, there is something called native application development and so on, which you can make use of C, C++, but normally it is preferable not to do that unless you're forced to do it. And only under certain circumstances you would resort to making use of what is called as native application development and so on. So this is the Java support that is provided for you called as the Android runtime, which is composed of the Dalvik virtual manager and core libraries. And so when Android applications run, what is unique about Android is every application runs in its own process with its own instance of the Dalvik virtual machine. So that way you provide sufficient separation between applications. So every Android application runs as its own process, as we will see when we go into the later part of this chapter and the next chapter. And the Dalvik virtual machine is the one that enables, that is the support virtual machine for the Java applications there. It is what is called as a register-based virtual machine. I won't go into more details of this. We don't really need it in this course. If you want to study a bit more about Dalvik VM, again, there are documents in the developer's website that you can look. Okay. Now, the Dalvik virtual machine itself expects files to be presented to it in this format called as the DEX format, or the Dalvik executable format, which I will talk about a little bit in one of the later slides. Okay. This DEX format is created from the Java code that you write within your application, and all classes that you write is transformed into the DEX format. So when you write a Java code in a Java file, it is converted by the Java compiler into a class file. This is what normally happens when you compile Java programs. But then after this, we make use of the VX tool, and that converts the class files into DEX files, which is what is used by the Dalvik virtual machine. Okay. Now, underneath, the Dalvik virtual machine expects the hardware to be supported by the underlying Linux kernel. So the kernel deals with all the hardware-related functionality, and then exposes a nice, clean interface for users to make use of it. In operating systems course, you have studied a little bit about kernels and what kernels support and so on. So Linux kernel is not that much different from what we have seen before. What does the Linux kernel provide? The kernel is the underlying operating system which supports multiple processes, threading, multi-threading, and so on, memory management, process management, and so on. This Linux kernel is an optimized Linux kernel for the Android environment. So as I said, this is not a stock Linux kernel from kernel.org, but instead it's a specially prepared Linux kernel. Some portions of the Linux kernel have been replaced by things that are more conducive to run on a low power device like a mobile platform. Okay? So the kernel basically hides the underlying hardware from the upper layers. So obviously this needs to deal with the underlying hardware, and that is done by using a whole bunch of drivers. You all have heard about device drivers and so on in your OS course. If you haven't heard about it, don't worry about it. We are not going to deal with that detail in this course. Okay? But if you have curiosity, then you can learn more about Linux kernel itself and how you write device drivers in Linux and so on. A very interesting topic in its own right. Wonderful area to study in its own right. And this provides all the provides the abstraction that is required by the higher layers and hiding the details of the hardware. So different handset manufacturers will have to take care of porting this to their specific platforms. So HTC will have to tinker with this to fit to its underlying mobile device platform. Similarly, Samsung will have also to tinker with this to put in the appropriate device drivers in place, which will handle the screen, all the different input-output functionality that is provided within their platform and so on. So if you have interest in doing that, that is again another area to study, but although not in this course, how to port Android to different platforms. It's a fairly involved game, so this is not for this course, but if people have interest in that, we have played around a little bit with that ourselves in some of the projects outside of this course. But interesting area to study yourself. How do you port Android to different platforms and so on? Okay?